into cylindrical coordinates. Maybe you know that Cartesian coordinates are not the right coordinate system to use, but spherical coordinates are also not the right system to use. Right. There's going to be times where you think you have a cylindrical symmetry in your problem, and therefore a cylindrical coordinate system is the most appropriate. So let's go ahead and define what that cylindrical coordinate system is. I will go ahead and have my x, y, and z components again. I have a point P in space. P, we could write those as P, X, Y, Z. But instead of defining them in terms of X, Y, Z or some sort of vector from our center of our coordinate system, we're going to define them with a set of different coordinates. Right? So I have my point in space as is some height above my xy plane. We're going to call that height z. It is some distance s from the z-axis. Right, so that is also the same as this distance down here. It doesn't need to be moderated anyway when you make that projection. And then I can also have some other angle, my azimuthal angle, call it phi, which starts at my positive x-axis and rotates around towards the positive y. With that, I know that my z, let's go ahead and define what our coordinates are. We have x, y, and z. In Cartesian, in cylindrical, z is still just z. And then we need to do our projections for x and y. Okay, so if I take my distance s and do the projection onto the x-axis, that becomes s times the cosine of phi, and y becomes s times the sine of phi. So now you have the conversion from cylindrical to Cartesian coordinates. All right, and now I have a new set of unit vectors, and therefore I'll have a new set of infinitesimal lengths that we need to account for. So let's go ahead and draw our coordinate system again. I have this point P. It's at some distance z up. All right, this is my distance s. So then I have a new vector s hat, which points in the direction of s. I have a vector z hat, which points in the direction of z. And I have a new direction, phi hat, which is the same as in spherical coordinates. So that means my infinitesimal length is then dl in the s hat direction plus dl to phi next in the phi hat direction plus dl z in the z hat direction. If you can then figure out exactly what these are, you can then build your infinitesimal area elements and infinitesimal volume elements like we did for spherical coordinates. But I'll let you do that on your own. And just like we had derivatives in Cartesian coordinates in terms of gradients, curls, and divergences, and those changed what they looked like in terms of spherical coordinates, those also look different in cylindrical coordinates.